This video focuses on finding the inverse of a relation, and we're going to start off by finding the inverse of a set of ordered pairs. So the first thing we want to identify is what is an inverse. The definition of an inverse is interchanging our x and our y of our ordered pairs. So if we have an ordered pair, x, y, and we want the inverse of it, we just interchange the y, comma, x. All right, so let's do an example. So in the blue here are some ordered pairs. And we're going to go ahead and graph those ordered pairs. So the first ordered pair is over 1, up 2. The next one is over 2, up 4, over 3, up 6, over 4, up 8. So there are our 4 ordered pairs. What we're asking you to do is identify some questions here. Number 1, is this relation a function? If you remember the definition of a function, it has to pass that vertical line test. So if you imagine this first vertical line, next vertical line, next vertical line, next one, it only touches one time at each of those places. So yes, it does pass the vertical line test. So it is a function. So I'm going to go ahead and graph those again quickly for us. All right. Now we're going to go ahead and find the inverse of this relation. If you remember from the definition right above, we're going to go ahead and interchange the x and the y of each of the ordered pairs. So I'm going to do those in a different color. So the first ordered pair we're going to interchange. We're going to now have 2, 1. So where that will graph is over here at over 2, over 2, up 1. The next one, 2, 4. Interchange will be 4, 2. So over 4, up 2. The next one, 3, 6. Will now be 6, 3. The last one, interchanging 4, 8, is now 8, 4. All right. Now, I want to connect some points here and there. Notice that these 2 points are going to be symmetric about the line y equals x. You're going to hear about this more later. Y equals x is the rule for when 2 graphs are inverses of each other. They're going to be symmetric about this line. So we're going to graph this line now. So this is a line. It has a slope of 1 and a y-intercept of 0. So I'm going to go ahead and graph that out. So a y-intercept of 0 and a slope of 1. So we're going to go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And we'll continue that. I'm going to go down the other way. Now imagine this imaginary green dotted line. If you were to fold it upon that coordinate plane, the red and the blue lines would smash right up on top of each other. This will happen every single time when they are inverses of each other. We can show that 2 functions are inverse of each other about the line y equals x. All right, is the inverse a function? So if we look at this red graph now, and we imagine drawing vertical lines again, it also passes the vertical line test. So it also is a function, yes.